Hi and welcome to Takniki Gyan Guru. Before we jump into today's topic, make sure to show your support by giving us a thumbs up, sharing this video, and hitting that subscribe button if you haven't already. Now let's get started. In this video, we will walk you through understanding ML.NET. Let's dive right in. So ML.NET is open source machine learning framework developed by Microsoft for the .NET ecosystem. It enables developer to build custom machine learning models and integrate them into .NET applications, including desktop, web, mobile, and IoT applications. ML.NET allow developers to perform various machine learning tasks such as classification, regression, clustering, recommendations, anomaly detection, and more. There are some key features of ML.NET. So first one is integration with .NET ecosystem. ML.NET seamlessly integrates with the .NET ecosystem, making it easy for .NET developer to incorporate machine learning capabilities into their applications. Next one is support for various learning tasks. ML.NET provide APIs and algorithms for a wide range of machine learning tasks, including classification, regression, clustering, recommendations, time series forecasting, and anomaly detection. Flexibility and extensibility. ML.NET offer flexibility and extensibility, allowing developer to use custom machine learning models, feature engineering transformation, and evaluation matrices. It also supports interoperability with other popular machine learning frameworks like TensorFlow and ONNX. Scalability. ML.NET is designed to scale from small to large dataset and support distributed training for training model on large dataset efficiently. Next one is cross-platform. ML.NET is cross-platform and support Windows, Mac OS, and Linux operating systems. It also supports various deployment scenarios, including on-premises, cloud, and edge devices. Ease of use. ML.NET provides high-level API and abstraction that simplify the process of building and training machine learning models. It also offers tooling support in Visual Studio and Visual Studio Code, including code snippets, intelligence, and debugging capabilities. ML.NET empowers .NET developers to leverage the power of machine learning in their applications, enabling them to build intelligent solutions for wide range of use cases. So we'll talk about ML.NET architecture here, each and every component when we are building a AI ML.NET solutions. So first step, in the first phase, what we do is we load the data loading. So we load the data in the form of text, CSV, and databases. This is few one. So we can also have different data sources. We have mentioned few one here. So there are a lot of data sources. Data from these data sources we can inject our data in this phase, right? So once we inject the data, we have the data. Now we will move to the next phase where we transform the data. How we transform? We either normalize the data, we have to clean the data, we have to validate the data. That sometimes called cleaning, right? In the data cleaning, for example, like we have the data in Excel format. In the Excel format, maybe we have missed some headers, or some of the fields are missing. So can we replace that missing field with either zero or null values? Or if in some of the row there is no data, required data. So can we remove some of those rows? So these kind of data cleaning is required. So that is called data transformation. So we do the data transformation in this phase. Then model building. In this case, we create a model based on the data ingested. How we model, we have to apply some of the algorithm, AIML or algorithm. So how, what are those algorithms? So we will talk about few one. So later on in the latest videos, we'll talk about in details of these algorithm. So first of all is the classification. We have used the regression or recommendations. We have more. So we have to apply some of some of the algorithm based on our data. So once we apply these algorithm, sometimes these algorithms already available, right? You can create your own algorithm, or you want to use this algorithm. Top of that, you want to create some more small changes on this, you can do that, right? So based on your comment, you can select your algorithm to build your model. Once the model is built, then we have to train these models. So how we can train this model? Using the test data. So we have to have some test data. We will push this test data and then train, right? So based on these test data, it will train your model. So sometimes we have the ratio of 80 and 20. So suppose we have 100 questions, 80 question will be for the modeling, and 20 question will be testing this model, right? Or training this model using these 20%. This is not a you know fixed ratio, because of we have already trained this data. Based on this training, it will answer your questions, or predict the data based on your training. Then we will evaluate. How we will evaluate? We will evaluate the accuracy, right? So whether it is 80% accurate, 20% accurate, 10% accurate. So based on your accuracy, you can go for the further, right? Either you want to cancel or you want to go further. Okay, 80% is fine, then you can use this model for the further process. So once the evaluation is done, then it will generate a model, trained model, right? AI, trained AI model. This model will be used from the web applications, API, or we can say they deploy somewhere, and then we can use this model to the web application API, mobile applications, and the desktop applications, or some further like IoT and cloud application. We can use it. ChatGPT is also pre-trained model, right? And it is deployed in the ChatGPT servers, and we are using this model in our applications, right? Similarly, you can create, you can deploy somewhere, and you can use maybe an application, mobile application, web application also. So once it is done, then you can you know do the performance improvement or scalability, right? So how we can do that? Either you can scale your model like one node to multiple nodes, right? And based on the load on your model, you can increase the nodes scalability, right? Or the performance, you can see if it is not perform well, then what you can do based on this, maybe scalability, or increase the CPU, or the infrastructure capability. We are just understanding the architectures and the ML.NET. In this video, we will not talk about the demo. We'll come back with a new video where we'll show you how to create our model, and train the model, and then use that model in our application. This will end to our video. Thank you so much for watching this video. We'll see you soon. Good day and bye.